For those of you that don't know me, my name is Whitney Weeb, and I'm the manager at Mesquite Groundwater. And I would like to welcome you all back. Today, we're going to talk about different projects around the state utilizing science. And it's my pleasure to introduce our first speaker, Lynn Smith. He's the general manager at Rolling Plains GCD in Seymour. He is a licensed professional geoscientist and has a bachelor's degree in aquatic biology and a master's degree in environmental science, both from Tarleton State University. Please welcome the plain and dry cheeseburger guy, my friend and predecessor, Lynn Smith.
There are stories that could be told about Whitney as well, but I'll refrain from that. I may need instruction on how to actually use this thing. Awesome. Okay, so back. All right. You know, I was a moderator in the room next door at the last session. They don't let you touch the remote control as a moderator, and now I've figured it out. So we're good. Okay, first off, before I get into my presentation, I would like to share that I am the presenter. There's a lot of contributors. Some of them are in this room. Geosystems Analysis, working with Mike and Lindsay. Dunaway and Associates, Matt, Derek, and Eric. Garrig Inc., Mike and Rusty, and RMBJ Geo, Ray and Amy. So beyond that, my staff, 2 of the 3 are back in the back, waving, yeah. Right. I had them sit in the back. They can't throw things this far. So here's our outline. We're going to talk about statutory authority, just in general. We're going to talk about a little bit of geology of the Seymour, surface water resources, what we look at to identify potential sites, and then finally, we're going to talk about at least maybe part of one case study. Adam reminded me, it's like, Lynn, you got 30 minutes and 50 slides. This is not going to work. It's like, it's okay. It's okay. So, MAR, in Texas Statutes and Rules. Well, it's right at the center of that whole surface water, groundwater interaction issue that we can't seem to get resolved. Chapter 36 provides a lot of things. That's, something that GCDs understand, Chapter 36, but there is more to it than that. So 36103 provides land use for various things, including recharge. 1071 provides recharge enhancement for management plans. And 1086 allows for joint participation in a recharge project within a GMA. Like I said, that's the area that we tend to work in Chapter 36, but there is more. Chapter 27, Subchapter H, regarding recharge projects that may or may not be under the authority of TCEQ and may or may not need a permit. We're going to talk about why they may or may not here in a little bit. Chapter 11, surface water. Chapter 16, funding. Chapter 17, state and regional planning, which also has a lot to do with funding. And then there's the federal stuff. We're right in there with the Clean Water Act. We're right in there with the waters of the U.S. The Clean Water Act's been pretty stable for a long time. The waters of the U.S. is a moving target. Lots of things to consider there. So think about what type of recharge project you want to do just in a big picture. Think about what your water sources might be. Think about what your receiving aquifer looks like. And then go sit down face to face with TCEQ and have a conversation with them. We did that, and it paid big dividends. They showed us some things I'm going to show y'all. People there that you need to interact with are the folks in the underground injection control, and the folks in the surface water availability program. Okay. If you know for a fact that you're dealing in an area that has a wetland, you might have a delineation done first. You need to know if it's a jurisdictional wetland. If it is likely a jurisdictional wetland, get the Army Corps of Engineers involved up front before you start doing stuff. It'll save you a lot of problems later. And by that, I mean save you a lot of money later. Okay, real quickly, Seymour Aquifer Geology. It's a sand gravel aquifer. It runs anywhere from 30 to 90 feet thick. That includes the sand and the clay and the gravel all together from the top of the ground down. It's not a 90-foot thick sand, 50 feet, whatever. So it occurs in pods in about 20 counties. It's a very young aquifer. One of my junior staff members, she used to be a senior staff member, but now she's a junior staff member, reminded me that it's about the same age as the mammoths, but not the woolly mammoth. It's about 12,000 years old. It's young. It's never been covered up with anything else. In that area of our district, ag and public water supply are the major users. Really, we could just talk about ag. They probably use 90% of the water in the Seymour. We've got regional declines over the past 5 or 10 or 20 years. So the little brown patches are the Seymour aquifer. It's a major aquifer, but it consists of all these little individual pods, and what happens in one pod has absolutely nothing to do with what happens in the next pod because they're not connected. That's some of those regional declines. So, surface water, source water options. Well, we could use Brazos River water. There's some issues with that. Mainly, we don't have any water rights to the Brazos River, and the water quality in the Brazos River is bad in our district, I think would be a fair way to put it. It's salt water. It's brackish water by the time it gets down to Lake Possum Kingdom, and as more freshwater zones come into it, it becomes a little bit fresher by the time it gets down to Lake Granbury, where it starts to become somewhat usable for drinking water. But in our area, TDS could be anywhere 15, 20, 30,000 parts per million. Not a good source for water. The creeks and ponds. Again, I'm going to show you something about some pesky blue lines. So that leaves us with stormwater, and that's actually where we're working at. And that consists of sheet flow, ephemeral streams that don't have blue lines on a topo map, and ponded water that's not a pond. So a little bit of advice. Avoid blue lines on those old 24K USGS topos. That's where the blue lines are. It shows the creeks, right? Areas without blue. I happen to pick airport. Maybe there's an opportunity to do a recharge program there someday. It's not state-owned water. That is state-owned water. So, in our district, what we did was an initial desktop study, 22-23. It identified some subbasins with recharge potential, did that very well. It had a few issues. Some limiting factors were the topography data that we had available at that time was not really adequate to properly define some of those subbasins because the area in the rolling plains, it's mostly plains and not a whole lot of rolling, so it's pretty flat. That leads to some issues trying to define exactly where those basins are. Also, there was some higher resolution precipitation data that was available at our district or to our district that our consultant did not realize at that time, and that resulted in kind of some communication gaps, and we felt like that was probably better in the study that was done 23 to 25. The topography data is still an issue in the more modern survey, but we used more robust precipitation data, which helped a lot, and a better ranking system to look at those subbasins. So what that basically did is it created a reusable site screening tool. Now, if we find a landowner that happens to be willing, that has an area that looks like it might occasionally flood, with an email, I can get a site screening done in a matter of a day or two because that tool is already built. Very helpful. Obviously, GSA is the one that developed that tool for us. So more on identification of those sites. You know, desktop studies are great, but they don't capture the landowner mindset. Like all the rest of Texas, my district consists of probably 99, maybe 98% privately owned property. So, you know, this is without landowner cooperation, this is a dead project. We're not going to go out and do condemnation, things like that. We're going to get that land to do these sites the old-fashioned way with money. So why do we do that? Well, we work with personal relationships, public relations, personal relationships. I had to do lots of peopling, and Whitney will tell you, I don't people well. So now we're going to move into the meat of what I really think is what I'd like to talk about. Our case studies. Hopefully I'll get through the Myers case study, and it's the one that's important. We've done the most work on it. It's more than 17 acres in Haskell County. We have a signed contract for purchase. It's a lease with an agreed price if we purchase and go forward with that. We've got subsurface testing kind of ongoing. I'm going to show you some of the initial results from that testing. There was limited well data available. We've got another site, it's called the Bufkin site. There's lots of well data there. It's just kind of not a very stellar site in some ways. In other ways, it's good. But the Myers, you know, we had limited well data, but it showed, you know, pretty variable geology across the site. The watershed itself is somewhere around 3,000 acres. It could be as much as 4, but we think for now we're using 3,000 as kind of our number for that. It's mixed rangeland and cultivated, primarily rangeland, and that's a positive for us because one of the bigger problems with infiltration basin type recharge projects, sites, is clogging. So if you've got people doing a lot of plowing, that stirs up a lot of fine sediments and they come down and get into your basin, clog things up. So having mixed rangeland out there, that rangeland is good for us because that captures those fine sediments before they ever get to our site. This is what these sites look like. This is a pretty typical picture. We've got 3 or 4 or 5 sites we've kind of talked about, and they all sort of look like this. These sites are frequently flooded. They are typically not cultivated at all because of that reason. And, you know, the only real purpose they serve in some ways is that there is some wildlife habitat there, and that's something that we're cognizant of, and you know, we want to develop these sites in a responsible manner, considering the wildlife that may be there. This is just kind of a graphic of what a surface infiltration basin recharge system might look like. I could have given you an engineering drawing, but this probably is just as accurate for now. So when it rains, water hits the ground. The ground near these sites tends to be clay, so it's not soaking in very well. Runs off into a settling basin, runs out of the settling basin into the infiltration basin, which is excavated through the clay layer into what we hope is coarse-grained sediments. So when we're out doing our site investigations, that's really what we're looking for, shallow, coarse sediments that are connected deeper into the aquifer. Okay, back to that TCEQ thing. One of the things you need to worry about is if you can avoid a TCEQ permit by choosing your construction style, it's probably a good thing. The excavation on your left is probably a well, and it's subject to UIC if you're using it for injection. Is this an injection well? The excavation on the right is wider than it is deep, which probably makes it not a well. It makes it an excavation. Now, I don't suggest that you go with this exact measurement, but gradationally, what TCEQ is more concerned about is deep excavations not very wide, and what they're not terribly concerned about is wide excavations not very deep. We did do a limited environmental assessment, one for our internal use. You know, we want to make sure that we're being environmentally responsible with this work, these projects. The other, we have a TWDB ag grant on this project, and in order to do construction with an agricultural grant, you have to do a limited environmental assessment, and you have to do an engineering feasibility study. So these have to be done up front. You can't use grant funding for this part, but we did that. So when we look at the data that we're trying to gather, well, subsurface data, we've got water quality data, we've got all these different types of things that we're doing. So here's our existing data. The blue wells are water wells. Those are potential locations where we could take a groundwater sample, and we did. We also took surface water quality sample. Those were a very extensive and expensive suite of things we analyzed for. Those samples run about $3,000 a piece, so we don't want to do a bunch of them, but we want to be thorough. We also had some oil and gas logs in this area, oil and gas wells, plugged wells, maybe some abandoned wells, I don't know. And then there are some wells there, some water wells that we have ran geophysical logs in as well. And the guys with Upper Trinity actually come over and run those logs for us, which is real helpful. We don't have that equipment ourselves. So getting ready, one of the things that we're doing is we run geophysical lines. So you can imagine trying to run cabling and stuff for geophysics through that type of brush. So we've got, we go out there with tractor and shredder and shred down some of the Johnson grass and clear some of the brush in small areas to collect data. This is some of that geophysical data collection. That's what a towed TEM system looks like. That's resistivity. There's one of my other staff members doing some survey work, elevations. This is an example of a well log that's near the Myers site. You see that sand up there that's up above 10 feet? That's a pretty positive sign for us. Now, when we went in and started doing pit excavations on the site, we found that that sand was not continuous. So we're going to need to do some more work to kind of determine exactly what the extent of that sand body is. That's some of the geophysics work that we did. It does show variability across the site, for sure. So when we got ready to do some excavations on this site, we needed to make sure we weren't going to hit any what I'll call orphan oil and gas casings that happened to be buried. So we did some magnetometer work. I'm going to call it homebrew magnetometer work. And we did find some anomalies. So we avoided those anomalies for now. Later, we'll go out and figure out what they are. It could be a beer can. It could be an old oil and gas well. I'm hoping it's a beer can. That's what our homebrew magnetometer actually looked like. We used a cell phone. We'll talk about that later. Here's the results from, or some of the results from our water quality. The water quality is, I'm going to say, similar at that site. It's not perfectly aligned, but probably okay, is my gut feeling. You know, we've got the samples ran. We're going to send that off to a geochemist to give us a real opinion. I'm just a geoscientist, right? We installed a stream gauge to see what was happening at the site when it rained. The first couple of weeks, we got a little blip over there, right there. That was about a 1-inch rainfall. But look here, when it rained 3 inches, we got over a foot of water standing out there around the rain gauge. And then something else interesting is the slope of this line right here and the slope of this line. I did some math and looked at pan evaporation rates. That's what that slope represents. So what that's telling us is there is zero water infiltrating into that site. We suspected that was the case because it's clay at the surface. But again, we're going to excavate down to what we hope is a coarse material. And I saw your 5 minutes, and I'll raise you 10. So our week in the field, I was the excavator operator. It's the best job there. It kept me out of the hair of our consultants. I didn't sit there and ask them questions all day. I just did my job. So you see over here some samples laid out. That starts at 1 foot intervals all the way down through here and then ending there. I think this one was probably about a 16-foot pit, 14-foot pit. And we did see in some of the pits that we didn't find any coarse sediments like we were looking, but there were a number of pits that did have coarse sediments. Unfortunately, the week ended before we really were finished with our work. So we're going to go back and we're going to hit that again, maybe in September or October. That's what those pits look like. This is the first time I ever got to do this. I've always worked in the Trinity Aquifer. You don't dig pits in the Trinity Aquifer. The water's way down there. This was cool. We did some cylinder infiltrometer testing also. Of course, I say we. I speak loosely about the we. It was GSA's people that was doing the cylinder infiltrometer testing and the descriptions on the pits. So what we found is water doesn't soak into clay at the surface very well at all, but there's more work that's being done on that. We also did some at depth. So what are we going to do going forward? Well, we're going to do some test wells, and with those test wells, we're going to do some aquifer testing. The primary reason to do that, one, is to get another water quality sample, but also to give us some transmissivity and storativity values specific to that site that we can utilize for some other work, like a mounding analysis. You don't want to put water in the aquifer and the aquifer not take it very well and start mounding up and keep water in your infiltration pond. That's not ideal. So, you know, pending all of that, I think acquisition on this Myers site is probably a maybe. Somewhere between maybe and probably right now. Then we'll do engineering design, final engineering design, sending that up for bid, construction. And then, of course, there's that monitor and maintain. We don't just build these things and turn them loose in the wild. We want to know that they're working. We want to monitor any changes in water quality. And they are going to need maintenance. These things clog up. You know, they may clog up once a year. They may clog up once in 5 years. We don't know that for sure yet. That's going to be something that GSA is going to work with us and kind of develop an operations and maintenance manual for these sites. And each manual will be a little bit different. Okay, I'm going to show you a little bit about the Bufkin site. If we do the Bufkin site, it's going to require some different type of design, which is going to be quite a bit more expensive. The reason for that is the clay extends all the way down to basically water level almost. So this distance is not far, if at all, and it would be cost prohibitive to excavate this all the way down into that sand. So we're going to basically, if we do Bufkin, we're going to use a reverse tile drain type setup. And I probably got a photo of Bufkin just to kind of show you. There's some of those wells I was talking about. Lots of wells around Bufkin. Water quality is much more similar at Bufkin, which I thought was interesting. Those blue and red dots are very close to each other. And that's what that site looks like. 4 months out of the year, it is flooded, which makes field work challenging, but you know, it's dry right now, so we can work out there at the moment. So I am going to end my presentation now. In the tagged materials online, the rest of my slides are on there, and you can look at those at your leisure. But I want to save some time for questions and other speakers. I can't have the whole hour and a half. If you'd come up to the mic, please.
I'm going to ask a very simple question. For the Myers site, you said there's no infiltration. So what is are you going to just dig deeper pits to transfer the water to the aquifer?
I said, what was you said? I said there's no what?
Infiltration.
Infiltration at the surface.
Okay.
So our intended design is to excavate the clay.
Okay.
Down to a coarse material. We're hoping that coarse material is no deeper than about 7 or 8, maybe 9 feet. But some of the pits we excavated 12 feet deep, and they continued to be clay or caliche, something not coarse-grained material. But we also excavated a few pits that were coarse-grained at, say, 7 feet, 6 feet.
Okay.
And
So
that's ideal for us.
So you're trying to avoid UIC permitting.
I'm sorry?
You're trying to avoid UIC, underground injection control permitting, so you're not going to try to put it directly into any wells. Is that correct?
No, these will be direct infiltration not in the pits, but this is going to be a large, like a 5 or 10 acre. You would call it a pond if it was full of water.
Okay.
But it'll be a basin.
Sounds like a great idea.
It'll be a basin. We don't want to inject it into a well for a lot of reasons, permitting among them, clogging, maintenance, expense.
Okay. Thank you.
Yes. We've got time for maybe one more question. Okay.